Hello and welcome to the 7th episode of the RockyTerrain podcast. I'm Thomas, and with me, as always, my good friend Dennis.
Hello there.
Today is February the 4th, when we're recording, and this episode is probably going to launch tomorrow. And today's episode, we want to talk about Mount Saint Helens, and especially the large eruption of the 1980s. So if you're interested in that, stay tuned. Otherwise, let's go into our introduction part that still has no name.
It's gonna have one eventually.
Yeah. Dennis, is there something you want to tell us?
This already sounds like some kind of accusation, like backhanded accusation. Is there something you want to tell us, huh? Yeah.
What did you do?
Actually, first of all, you might hear a little bit more of a reverb in my audio, a little bit more than usual, because I am currently recording in our living room. I can't record in the bedroom where my PC is at. You might remember I've announced that I'm going to get a good PC, and I had some trouble with said PC because it wasn't delivered on time. And now it has been delivered and it's set up in the bedroom. But unfortunately, my girlfriend has to get up very early for work tomorrow. So yeah. We have already talked about Thomas having some lag, so he hears me about 1.2 seconds, something like that, after I've started to speak. So there is a certain delay, and we hope that we could finally eliminate that delay when I would finally have a good PC. But yeah, now that it's there, another reason for me not to be able to use the PC. An understandable reason. I mean, she even offered to lay down in the living room for as long as we record.
Oh.
But yeah, no. I told her,
no.
go to bed.
No.
No. Exactly.
But
People
nice
will unfortunately, people will just have to deal with a bit of reverb. But
Actually, it's good. So I don't hear anything.
Okay, yeah. But next time around, we are going to have a bit more fluent conversations. Definitely.
If I would cut the episode tomorrow, I would include a clap sound after you would have said that your PC is here.
Yeah, maybe I should tell that too. I am going to, for the first time, attempt cutting the episode. Until now, it's always been Thomas' job. Because I always listen to the first draft of the episode. I mark the times for Thomas. And yeah, tomorrow it's going to be only me because Thomas is going to be very busy tomorrow. So if there is anything in terms of bad cutting or anything going bad because of the technology, it's me, folks. It was me. Yeah, but actually, overall, not really much new for me. Working in the collection of the Natural History Museum continues, and basically nothing has really changed too much. What about you, Thomas?
No. Okay, that wasn't really much.
Status quo.
Yeah, so I'm currently very busy because first of all, this university exams are now coming on the way. Also, we have to do an absurd amount of small talks about papers in our classes. While I like them because I like talking about things, it's quite much with all the exams. So for tomorrow, I think I didn't tell you, but for tomorrow, I have to do a talk about the nature paper that talks about the magma ocean on the moon. It's a very complicated topic. And it's a nature paper over 5 or 6 pages. And we have to comprise it in 5 minutes. Yeah,
Yeah,
that's
yeah.
going to be interesting.
You talked about that
Yeah.
some days ago, I think. Yeah, you kept mentioning it, but only now is it that I really think about it. 5 minutes is truly short for that.
Yeah, and we're not allowed to do PowerPoint. We have to use the Zoom whiteboard function and
Uh,
draw.
yeah, you told me that. Oh man.
Yeah.
So it's going to be interesting. Are you able to record that for me?
I don't think so, but I can do it again after in the next day or so.
Let's see.
Yeah. Yeah. So otherwise, exams. This week is the Plan Map Winter School. So that's it's yeah, how do you say that? There are some universities or institutes, planetary science institutes within Europe, within the EU especially, that so I try to think how to explain that actually. It's a 1 week course and 1 week school in which you learn planetary mapping. And they provide it for everyone who thinks I want to get better at that. For example, PhD students, but also master students or even bachelor students. So there's several courses, several lectures, and then there are also some practical courses that you had to sign up to. And yeah, they're going to explain you persons that are very educated in that field and had made many planetary maps gonna explain to you how they do it. And that's actually really interesting. So yesterday, for example, was the Mars session, and I also was part in the practical part, or I did take part in the practical part, and we learned how to precisely map on Mars and learned some tricks and stuff like that. And tomorrow is an 3D part where you learn how to make 3D models and stuff like that, and then also how you can look at them with VR. So
yeah,
that's also going to be interesting.
Yeah, that's pretty cool. That is.
I mean,
really
I showed you Mars with my VR headset, right?
Yeah, you did. You did.
Yeah, so I'm looking forward to tomorrow. Yeah, it's pretty interesting. That's a cool thing, but also, I mean, it's a lot of work, but it's additional stuff currently.
Yeah.
Because then there's also the paper about my bachelor thesis that I'm writing currently. And then also in March is the LPSCs and the Lunar Planetary Science Conference, and now the schedule is online, or it's going to be online tomorrow, but you already know what you have to do. And I have one talk, so something that I have to pre-record till March the 1st, I think. Yeah, March 1st. And then I have to do a poster. So February is going to be busy.
Yeah, sure sounds like it.
Yeah, so that's, I think, all about me. There is something in planetary sciences that I want to talk about, and this is that actually in 14 days from now, when we're recording, the new NASA Mars rover, Perseverance, I hope I pronounced it correctly, is going to land on Mars. So in 14 days, we will have a new Mars rover.
Do you want to tell us some details about that?
I thought about that, but honestly, I think that I'm going to write some facts for the next time or something like that. To give a small, I don't know, 5 to 10 minutes talk about that and what we can expect from the mission.
Would be cool.
So I think that's, yeah.
Just to celebrate having the new rover down there. Or up there, or whatever you want to say.
Yeah. Mars is now getting a very crowded place, very busy place. We have the NASA rover, then we have a Chinese rover at the end of the year. The next year, the ExoMars ESA rover is going to land. And yeah, quite some stuff. Okay, if this concludes our introduction for today.
Man, I don't really know whether we've ever had such a short introduction. I think we're not even.
Think so.
I think we're not even pushing 10 minutes.
I mean, you can't start rambling about dinosaurs again if you want to.
I mean, are we sick? Do we have fever? Something's clearly wrong today.
Stuff like this happens.
And
okay.
Before I'll actually start rambling, let's move on.
Yeah, exactly. Okay, so then we're going through a small break, and then we'll come back with our main topic for today.
Yes, indeed. So, after reviewing Dante's Peak at the end of last year, we both were pretty interested in the Mount Saint Helens eruption again. Because, well, while watching the movie, you could clearly feel the influence of the Mount Saint Helens eruption, which had occurred just some 15 years before the movie was released. And I think we're both pretty fascinated by this very eruption, just because of its sheer dimensions. But I would honestly like to ask you, Thomas, when was really the first time you heard about this eruption?
So the first times, I think I saw it in a documentary. We have it's probably something like the Nature Channel in Germany, and they were these eruptions. So there were these documentations. So there was first of all this documentation where they've shown horrific accidents and the human history, and they've gone through it minute by minute. And then there were some other nature eruptions, documentations. I don't know why I say eruptions. And yeah, I think this was the first time I got in contact with the Mount Saint Helens eruption, and it got me fascinated from the first time seeing it.
Honestly, Mount Saint Helens, I think also going back for me, it was always this, if there ever was truly any eruption I had in mind, I could just talk about from the top of my head, it was Mount Saint Helens. And ironically, the first time I heard about Mount Saint Helens was in a dinosaur documentary.
Yeah.
You remember?
What you mean.
Exactly. It was, I think, Dinosaur Planet, it was called. In German, it was called Die letzten Jahre der Dinosaurier, which translated means the final years of the dinosaurs.
Which I think is a beautiful name, actually.
Yeah, but they didn't even show the Maastrichtians, so they didn't show the final phase of the Cretaceous. They showed, what was it? It wasn't the Maastrichtian. It wasn't the final years of the dinosaurs. Sometimes these were way, way older periods of time.
Yeah, I never realized, never thought about that, but yeah.
But anyway, there's one episode centered around an eruption which occurred in the late Cretaceous in North America, and they compare this to Mount Saint Helens. And so, yeah, actually, this was the first time I heard about it, and ever since then, for me, it's been basically the example for a cataclysmic eruption.
Maybe it was even the first time for me now thinking about it. I don't know when I saw it really the first time, but it could be that this was the first time, because that was one of the first dino documentaries I completely was in love with.
Yeah.
I think I've watched this nearly every day as a child. But yeah.
Yeah. But as I said, after reviewing Dante's Peak, by the end we were pretty intrigued. We really wanted to revisit Mount Saint Helens, really try to, create this overview for ourselves and to share it with you guys out there of the events of the 1980 eruption. And maybe at first we should give some context, because we would really like to set the whole stage. We don't just want to start into the events of 1980 right away. We want to really give you guys a conclusive overview, which is of course going to be pretty much brought down to the most essential points still, but you are going to see why. Because there's a lot going on. Because the history of Mount Saint Helens, or the region around today's Mount Saint Helens, actually goes back quite a while. So maybe first of all, Mount Saint Helens is situated in the Cascade Mountains, which is a volcanic mountain range situated in the western United States. Washington State is where Mount Saint Helens itself is situated. And yeah, this magmatism, the volcanic activity there, stems from the nearby subduction zone on the west coast. So basically, this is where the oceanic plate to the west is subducted under the continental crust of the western United States.
Should I explain in like 2 sentences why there is... I just realized that why there is actually volcanic activity behind subduction zones? That's very easy to do.
Yeah, of course. Just go ahead.
So the subducting zone, which is the ocean plate in this case, is, well, full of, not maybe full with water, but it has a high abundance of water. And when this plate is now deeper into the earth, the water starts to, well, leave the plate because of the density and the pressure and the heat.
Yeah, it's basically squished out.
Yeah, exactly. And then because it's not as dense as the surrounding material, it starts to rise up. And while doing this, surrounding materials, the surrounding rocks are going to melt. And I don't want to go into detail of that, but you can get the rock under these pressures to melt also with water. So I don't even know if it's only water, but like any liquid you have can lead to a farther melting point of rock. And that's why behind these subduction zones you often have these volcanoes that are situated in these beautiful lines, basically, volcano by volcano, every kilometers in these beautiful lines.
Yeah, maybe we could encourage everyone listening to go to Google Maps and go to Mount Saint Helens. You can zoom out and you will see that Mount Saint Helens is just some, I think, what was it, about 150 kilometers from the coast. You can actually then follow this whole mountain range, the Cascade Mountain Range. So you can actually see that it's kind of correlated with the coastline. So kind of parallel to the coastline.
Exactly.
Yeah, and exactly, Mount Saint Helens isn't just the only volcano there, but it's, as we've already established, the most famous. And the history of, volcanic activity in the area of the modern day Mount Saint Helens goes back about, not quite 300,000 years, 270,000 years I saw being given a few times. And just to put this into perspective, the oldest known remains of our genus and species, Homo sapiens, from Morocco are about 300,000 years old. So to give you guys an impression of how long this volcano has been active, it goes back about as long as we know Homo sapiens to exist, which is quite a long time. Not in geologic terms, but in general, from the human perspective especially. And this volcanic activity is, structured into different stages, so different phases when this volcano was active, because it began to truly be active in the so-called Ape Canyon stage. As already mentioned, began somewhere in the range of 270,000 years ago and went on to before 30,000 years ago. This stage is actually pretty poorly known because, well, over time, more and more eruptions occur and evidence is just obliterated. Everything is thrown through one another. Everything is, or at least some parts are remolten. Erosion is doing its thing. And therefore, it's really poorly known. It's divided into two phases. And there might have been a hiatus, so a break of activity for about 100,000 years. So for 100,000 years, nothing happened there. And then the volcano might have just started all over again. The next stage then actually is the Cougar stage from 28,000 to 18,000 years ago. So we had a break. The Ape Canyon stage ended about 35,000 years ago. Then the Cougar stage, the next volcanic stage, only begins about 28,000 years ago. And during this stage, there was a very huge debris avalanche, the Cougar debris avalanche, which was about the size or maybe even larger than the 1980 debris avalanche. And it reworked many parts of the older Ape Canyon stage. So you can already see that a debris avalanche obliterated the old deposits from the older stage. And this is something we have to face when trying to reconstruct the history of a place. Also, the Swift Creek flow took place, which was an andesitic magma flow, and it was the largest Mount Saint Helens flow. And this is maybe where we could give some information about different lavas or different magmas, because we are going to talk about different types of melts. There are at Mount Saint Helens melts which are basaltic, andesitic, and dacitic. And I think Thomas is going to be the one who can explain these things sufficiently.
Yeah. So there are some differences between it, but I think the most important part is the difference in the abundance of silicates. So SeO2, one silicate atom and then two oxygen atoms. So this is the most important difference between them, because the silicates can then build large polymers, is the word for that. So chains. Large chains, and these large chains then influence the viscosity of the material. So a higher viscosity means that the material is more viscous, of course. It has more SeO2, and also then it does not these beautiful basaltic flows you, for example, have these. It looks basically like water. You can only have that if you have a low viscosity and therefore a lower abundance of SeO2. And if you're, for example, dacite or andesite, then you have a higher SeO2 abundance. You have these chains, and then the material is higher viscous and therefore does not flow nicely. It is very rough, and it completely changes the eruption style of the volcano, for example. So if you look at the Hawaiian volcanoes, you have basalts, and then you have not these explosive eruptions, but just lava pouring out of the volcano and flowing away. And if you have, for example, a dacitic volcano, then you have these large eruptions just because the magma in the lava is so viscous and different than basaltic lavas.
Yeah, indeed. And this is, as I've said, going to be important. So just maybe remind, basaltic is the most liquid lava, essentially. You have huge lava flows. Andesitic, to a degree, the same thing to a degree as basaltic, but more viscous. And dacitic is, where the fun begins. Because dacitic, these are the most violent eruptions we are going to encounter.
And rhyolite.
Yeah, but
I don't think rhyolite was.
Indeed, I wanted to say the most violent we are going to encounter here.
Yeah.
Yeah, exactly. So the Cougar stage, as you can see, we had huge lava flows. Something we are going to encounter time and time again. So the Cougar stage ends about 18,000 years ago. And then we transition, into a break of 2,000 years. And 16,000 years ago, the Swift Creek stage starts and lasts until 12,800 years ago. Once again, a phase divided into two phases. First phase included pyroclastic flows, something we are also going to encounter later on. We had debris fans, different kinds of fans. I am not going to go into detail here, but one thing I want to note is that once again, these fans lay on top of older material. So once again, an example of something, some erupting material covering others, so that we have a more difficult time to try and unravel the history, because many parts of older eruptions are just inaccessible. And the second phase of the Swift Creek stage then had an explosive eruption phase. And maybe one thing Thomas could once again explain is, why are there even these different kinds of eruption types? Because, sometimes we do seem to have these these lava flows, and sometimes we have these explosive eruptions. And why exactly does this happen?
Yeah, so that's actually really interesting, because in generally this happens. This not only in the case of St. Helens, this happens more often, but it still is a weird phenomena. The point is, at subduction zones, you, for example, normally don't have basaltic flows. So basalt is not something you would have there, because basalt is something that we would get, for example, from molten material deep down of the earth. For example, the Hawaiian volcanoes, they have a plume that comes from deep in the mantle. And if this material then melts, then you would get basalt. But now at the subduction zones, we have material that already was, solidified before. And with solidified, I mean, again, recrystallized. So the oceanic plate is material that was created at the middle of ocean ridges. And then it got later then at the subduction zones reliquefied, or that's maybe the wrong word, melted again. So you have material that has already a longer evolution behind it, let's put it like that. So you would normally not get basaltic material. However, there are some points, some reasons where this can happen. So first of all, we can have maybe two sources. Maybe there was another source that could somehow have influenced. And then it could have maybe come to a mixing of materials. So two individual magma chambers that mixed, and maybe that happened. Or some separated, completely other source influenced strongly the eruptive style of St. Helens. Or what we could also have is that the material, so the magma chamber, has gone, evolved farther, and through time, then this evolution would have, ended in more basaltic material. However, it's really difficult to say at that point. So there are, as I said, some reasons why this happened, but we don't really know what exactly happened here. Maybe something that comes to mind when thinking about St. Helens is that we talked about this chain of volcanoes, but St. Helens weirdly does not directly fit on this chain. It's a bit shifted because of the underlying structure, the underlying surface. So maybe there is a reason behind that, but in the end, you can't really tell why. We have some ideas, but overall, I think it's going to stay a mystery.
Yeah, maybe I wouldn't go that far.
Yeah, I mean, with mystery, I mean, and it's extremely difficult to tell.
Yeah.
I mean, there's some ways you probably can do some with isotopes or like the isotope compositions, but it's really, really difficult to directly say.
Yeah. But quintessential here is there is something weird going on. Maybe mixing of material, maybe a long evolution of the material, but sometimes you have this phenomenon that basaltic magma extrudes at the surface here. Now we actually enter the final stage pre-1980, which is the Spirit Lake stage, which began once again after an eruptive break. It began at 3.9 thousand years, so the Swift Creek stage ended at 12,800 years, and now you have a break until 3,900 years before today. The Spirit Lake stage is very important for the 1980 eruption insofar as that it's the phase when the main edifice of the volcano as we know it today was not constructed but came about. It is divided into 6 periods, which once again I'm not going to go into detail here, but this is where we really get into time ranges at which we can be more precise. And the USGS on its website even stated that excellent preservation of deposits and numerous ages from radiocarbon and tree ring dating provides considerable detail for this stage. They also stated that it includes the most complex part of the eruptive history, which, it's might be. I don't know. We're not the experts here, but I would also say it's simply pretty well known. It of course we know that we know about its complexities because it's the youngest stage, basically. I mean, they said it themselves.
The most material of the stage.
Yeah, because it's the most surface near. It's been altered the fewest. But once again, I mean, it could be possible. I didn't really manage to get into too much detail how complex this is in comparison to the other stages. But yeah, maybe an example going back to episode 2. It's the youngest, it's been altered the least, and therefore it's at least one reason why it might appear as complex as it is, just because we know the most details.
Yeah.
Yeah, exactly. And the Spirit Lake stage also now is mostly dacitic in its eruption style, so mostly more explosive, and among them even the likely most voluminous explosive eruption that might have ever taken place there, because I've seen it stated that it could have been about 4 times larger than the one in 1980, which is considerable. And this doesn't mean that you didn't have any switch in eruption style, because andesitic and basaltic lavas have been recorded as well. Andesitic and basaltic eruption types.
These can sometimes even change. Oh, sorry.
No?
Yeah,
I was done.
Okay. Yeah, he was looking for a sec. Yeah,
it's going to end next week.
So these eruption styles can even change, on a very small scale, within one event.
Maybe if the reservoir changes, if more than one reservoir is taking part in the eruption, maybe? Or...
and also if the eruption goes long enough, then you would have some processes in the magma chamber itself.
Yeah, interesting. Yeah. But mostly dacitic. And what is significant for us is that the dacite dome on top of the volcano main edifice underwent significant growth in the 17th and 18th century. So pretty recent history, even in human terms. And this growth of the dome resulted in more elevation. And glaciation took place around the summit. Pre-1980s shape was slowly reached, and even still until the 19th century, frequent eruptions took place, and likely in 1857 the last really significant pre-1980s eruption took place. So what I would like to stress here is that now we've seen on which timescales this volcano operates. Please keep in mind that there can even be breaks of maybe about 100,000 years between eruption periods. And 110 years isn't really that large of a break. In human terms, yes, which might also be an interesting point for discussion later, in how much can we even really mentally be prepared for something like this, because volcano eruptions cannot even only jump between generations, but they can jump between cultures. Yeah, so maybe one culture might completely miss an eruption and the next one will be the first one to deal with it, so that you don't even have anyone from your specific type of culture who has experienced that.
Yeah, I think we can talk about it later, but in our discussion.
Yeah. So, shall we get into the main event?
Yeah, let's do this. What you want to do now is you want to go through the event step by step and going through the most important phases of this eruption event that took place in the 1980s. Now, as far as I know, you have some notes that go a bit farther than me, than the ones that I have.
Yeah. I have a bit more in terms of history, maybe, and you are once again the volcanologist here, quote unquote. You know more about it than I do. Let's put it that way. So what I found pretty interesting while doing my research was that, actually, I was pretty surprised because I didn't really know too much about Mount Saint Helens going in. It had been a long time since I ever really read something about it, and I really wanted to know whether people could have known about this eruption or whether it came pretty sudden. And the answer surprised me because it was a very surprising eruption in the end, but actually people had it under suspicion that Mount Saint Helens could erupt before the end of the 20th century, because there is a paper out there from Crandell et al. Titled Mount Saint Helens Volcano, Recent and Future Behavior, which is from 1975, 5 years before the eruption. And it states in its abstract, Mount Saint Helens volcano in southern Washington has erupted many times during the last 4,000 years. So once again, this last final active period, the Spirit Lake stage, usually after brief dormant periods. This behavior pattern suggests that the volcano, last active in 1857, will erupt again, perhaps within the next few decades. Potential volcanic hazards of several kinds should be considered in planning for land use near the volcano. And I didn't know about that. And this was stated this paper was referenced, and that's how I came to see it in the official USGS report on the Mount Saint Helens eruption. And that's pretty interesting because people were talking about a potential eruption in general.
Yeah. I mean, the interesting point here is that all these volcanoes that we know of that are still kind of active, they are going to erupt in the future. This is something that we know of. All these volcanoes, even near large cities that we know of, like Mount Fuji in Japan. Did I pronounce that correctly? Or the Popocatépetl at Mexico City.
Yeah,
like all these volcanoes.
I'm pretty sure you didn't pronounce that one correctly.
Yeah, but that's how we pronounce it in our lecture. Anyway, these volcanoes are going to erupt again in the future. They are. But we just still don't know when this will happen. Is it in 10 years, 20 years, 100 years? Difficult to say. But what I think is so interesting here is that they even say decades.
Yeah.
And that's interesting. That's something that I don't know. I didn't read the paper yet, but that's something that I actually want to read why they're saying that. So, do you know that?
Once again, didn't really go too much into this, unfortunately. I went over it, but basically the volcano was never truly inactive. I mean, I think it was never as active or active enough for immediate attention to be necessary. Of course not, but honestly, I focused mostly on the key points of this one because
it wasn't part of our research.
Indeed.
But I definitely want to go into detail of that because maybe in an update next episode. But I think that's pretty interesting.
Yeah, because I really I remember when I sent you this, you were pretty surprised as well to see that, hey, there is this paper 5 years before stating that it could erupt before the end of the century.
Yeah, that is interesting, yeah.
But now, imagine, it's winter in 1979 to spring 1980, and you live near the volcano, and you aren't really thinking too bad of the situation. And all the while, way down below, magma slowly starts to enter the volcano without anyone noticing at first. And then on March 16th, 1980, this is when the first true activity occurred in the form of small earthquakes, and as I read in a source, hundreds of additional earthquakes followed. And these were even picked up by a University of Washington USGS group seismometers for study of geothermal potential. So it was considerable, and this was when really real activity started. And then on March 20th at 3:47 p.m., there was a magnitude 4 quake. So the first really strong quake, essentially. And on March 25th, 24 earthquakes of magnitude 4 or higher were recorded during a period of 8 hours. So activity is increasing, magnitude is increasing, and this was the point at which new fractures, rockfalls, and avalanches were observed.
Yeah, and at that point, I think it's pretty clear that, I mean, we can't say if like there's really an eruption or like a large eruption coming along, because volcanoes are very difficult to really, gasp. It's not like your weather channel that can say like, "Ooh, tomorrow is going to rain." But
yeah.
at that point, we are at least pretty sure about that there is some strong activity going on, but we still don't know what it is going to lead to.
Yeah, and we are still going to see how difficult predictions are. Because that's what people struggled back then. After the Dante's Peak review, we both wondered, or actually, I don't know about you, but I was wondering in how far could the situation at Mount Saint Helens have been, or after the movie Dante's Peak, because the movie Dante's Peak really makes a point of we have to react quickly, and we shouldn't wait for too much evidence to just come across, because we could in the end just be overwhelmed by the eruption itself, because it comes too sudden in the end. And that because of that, I was thinking, hell, maybe someone didn't react properly. Maybe people didn't react quick enough, because that was the vibe I was getting from the movie, because it seemed to have been heavily influenced, but in the end, actually, I think it was pretty difficult to predict what would happen.
Yeah, it's extremely difficult.
Yeah, but I just found it interesting, because I think while it draws a lot from Mount St. Helens, this wasn't really what I would say happened at Mount St. Helens from the research I did, because...
no, I mean, they reacted. Definitely, they reacted.
Yeah, absolutely, and they reacted in time.
Yeah, most of the casualties that we have at Mount Saint Helens were people that were there because of work, or because they did not listen to the officials. So.
Let me quickly add something, because we just stopped at this increasing earthquake activity on March 25th, and talking about reaction on March 26th. Access to the volcano and the adjacent areas were restricted, and you had this different areas. I think it was a red area and blue area erected around the volcano. One with absolutely no access, and one with access with permission, or kind of something kind of like that was what they did. And at the same day, a Center for Research and Public Information press conferences was set up at the U.S. Forest Service headquarters in Vancouver, Washington. So this is when people saw something was going on and activity was increasing, and something was done about it. But then again, there was the problem with people who didn't want to leave their property, like good old Harry Truman.
Oh yeah, I think we're gonna talk about him later, didn't we?
Yeah, indeed. Not the president, by the way.
Did you see this image I sent you on Discord?
Yeah, I did.
So when you Google Mount Saint Helens, there is this section people also ask, and then the first is, what president died on Mount Saint Helens? It was not this Truman, different Truman, but yeah.
In preparation for this podcast, we both watched documentaries just to get back into the topic, not for research, because it was just to get back into the topic, just to gather some basic knowledge. And then even there, they made the point that this has no real relation to the president.
No.
Oh, yeah, but...
Must have heard it.
He has a role to play, but he's just one example, because he was over 80 years old, I think, at the time of 1980, the events of 1980, and he basically didn't want to leave his property. And yeah, this is going to become important later. But
yeah, we're going a bit ahead of ourselves here.
Yeah, that's the situation at the 26th of March. And then on March 27th is when things are really getting serious, because at 12:36 a.m., the first eruption in over 100 years takes place. And the unfortunate situation was that it couldn't really be seen because of cloud cover, but it was heard. And a large ash cloud could be seen rising atop the cloud cover. I read
up to 2
about
kilometers.
2,000. Exactly, yeah. About 2,000 meters high. And this actually even created a crater in the north part of the volcano's summit, about 60 to 75 meters across. There was ashfall and a 1.5 kilometer fracture northwest to northeast, running from the northwest to the northeast flank across the old crater, which opened. Yeah, and what I found pretty impressive was that this crater then grew to a size of about 400 meter diameter within a week. Grew very quickly, and this was already pretty alarming. But yeah, talking about the March 27th, the bulge is definitely going to be the main event. So go ahead.
Yes, on the north flank of the volcano, a very visible bulge evolved. And this bulge is going to be extremely important when we talk later about the eruption. So what happens maybe is that new material searches now for a new way to rise up to the surface, not the normal vent that it went before, but it searches for another way, maybe through fractures or anything else. And what probably happened, or probably is going to happen, is that material kind of builds up beneath this bulge, and that's why this bulge is evolving. And that is going to be pretty important when we later talk about the main eruption.
Yeah, and let's just really point out that we are not talking about just a small little bulge.
Yeah.
This is not a small part of the north flank. You have this 3 kilometer high volcano, 2 point something, and the whole northern flank bulged up. The whole northern flank just went, and in a pretty dramatic fashion, because the USGS stated in the final report that it grew about 2 meters a day, which is considerable. I mean, imagine, this is a whole mountain flank growing 2 meters out a day. And yeah, that's definitely impressive, and that's definitely some reason for concern.
Yeah, so that's normally something you would measure through tilt meters, for example.
You wouldn't even have needed them here.
Yeah, you just saw it with your own eye. Yeah.
Yeah, and this is, honestly, that's really, really impressive and really, really scary. Yeah, but that is really where things became suspicious, where things became really, apparently dangerous. And then one day later, on March 28th, on 2 a.m., there was a second 2-hour-long eruption, followed by several more ones. And we're not talking about major eruptions here. These are always kind of small eruptions, so not really threatening people in the wider area around the volcano. Precursor events, basically. But once again, observations...
Sorry, I think the delay is quite a bit strong. But the problem is, again, that now we say these are precursor eruptions, but we don't know that at that point. We don't know, is that it? Was it it? Was that all the eruption that is going to come? Or is there something else? At that point, I mean, maybe at that point because of this last bulge that evolved, but still, normally at this point you wouldn't know what is going to happen next.
Yeah. And that's what I think always comes through when reading through the literature is that, yeah, of course, you see that this bulge is developing, but at the same time, it's very difficult to predict how exactly this mountain is going to erupt. Because, I mean, just imagine you have this whole construct there and you can't really know all the weak zones, for instance. Knowing where weak zones are that's pretty essential to predicting how exactly something is going to erupt, and knowing all the details of that to the very far inside of this construct is difficult and very complex.
Yeah.
So yeah, exactly. Precursor events in hindsight, but nobody could really have known about anything more back in the day, I would say.
Sorry?
Yeah, you there?
Can you repeat what you said there for a sec?
I said that these were precursor events in hindsight, but they were not. Nobody back then could have known what exactly that meant. Yeah,
correct. Yeah,
good that you corrected me on that. I think it was a bit unclear as I formulated it.
Oh no, sorry, I just couldn't hear you.
No, I meant overall that you said that, precursor events, of course, but nobody could have said that. Nobody could have known that. But talking about estimating what is going to happen next, I would like to maybe insert at this point that public pressure also grew for people to return to their homes. There were people who were in the remainder of March and late or early April were feeling more safe again, because, I mean, for the remainder of March, you have one eruption per hour. Volcano is active. And late to mid-April, this is where activity lessened considerably to about one eruption a day. So going down from March 1 per hour down to 1 per day. Earthquakes still were at pretty high rates, up to 30 a day, magnitude 3 or more. And but eruptions lessened.
And harmonic tremors.
Yeah, exactly.
So harmonic tremors are also an important detail when we talk about the activity of a volcano, because these, what we call harmonic tremors, these are really the points where you can measure the magma moving. These are movements of the movements of the surface that were introduced by the movement of magma activities, by the movement of magma through cracks, through stones, by the release of gases, anything like that. And it's a very distinctive, that's why we call them harmonic, very harmonic and distinctive measurement that we can make. And this is always a really important part, because now we know, okay, magma is moving.
Yeah, but what did you say? Did they lessen, or did they remain?
They declined. Sorry, they declined after April. Right.
Yeah. Okay. Because so I didn't. 20. Yeah. Yeah. This was your area with the tremors of research.
Yeah. Sorry, I wanted to add that. It ceased by, I think, April 22, and then they were still there sometimes, but they ceased. Yeah.
Yeah, and so you had this lessening in activity. And at least, I mean, as I said, we watched documentaries for just really trying to remember the basic stuff. And there were some cases of people wanting to return to their homes because they said, at least I remember one videotape of an interview, a TV interview, where a woman said that she's not afraid of the volcano and she pays taxes for the land she lives on, and she wants to return to her property. And I mean, I don't know. At least some of those cases, I had the impression that this occurred during the phase of declining activity. Some people, like Harry Truman, didn't even want to leave in the first place. But it was stated that there was a pressure for restrictions to be lessened, which actually in some kind of way reminded me of the situation today.
Yeah, exactly.
Because when this woman said she's not afraid of the volcano and she wants people to leave too, she wants the government basically to lessen restrictions. I mean, good for you if you're not afraid of the volcano, but the volcano doesn't care. And this is going back to what we would like to maybe get across, that just because a volcano declines in activity for a month, this means nothing. Absolutely nothing.
Yeah.
And I mean, as I said, I don't really know the exact context of this very interview, but yeah, pretty telling in some cases.
Exactly, yeah.
And Harry Truman, actually, we both pretty much agreed on that before the podcast. He seemed to have been the inspiration for the grandma from Dante's Peak.
Yeah, he doesn't want to go away.
Yeah.
And she's actually living at this lake directly next to the volcano.
Yeah.
Like he also had. Like at least his lodge, his caretaker lodge was at Spirit Lake, the lake
Indeed.
Directly next to the volcano.
Yeah, the whole setup was just very reminiscent of her.
Yeah.
Or her setup was pretty reminiscent of Harry Truman.
Yeah. But back to the volcano.
Mm-hmm.
So what we also have during this time is the release of fumaroles. Now what these are openings or small cracks at the surface, and then volcanic gases like sulfur dioxide or carbon dioxide are released. And I actually have seen them in real life in Iceland. So I haven't seen a real eruption in my whole lifetime, but I saw in Iceland these fumaroles, and they stank like rotten egg. Was pretty cool experience, but
so you talk about how bad it smells, and then you're like, yeah, cool experience.
Yeah, I mean, I didn't care about the smell that much because it just was cool. Yeah. You had also sometimes this bubbling, weird, dark liquid kind of mixture between water and small rock fragments probably.
So awesome.
Yeah, made some cool images back then. Yeah. And these were sampled, and this also reminded me back on Dante's Peak, because Dante's Peak was actually pretty accurate about the measurements and about the monitoring of volcanic eruptions. So as in this case, samples were done, and they had high chloride, sulfide, and ammonia measurements. And this also shows you that, the fumarole self couldn't be sampled, but water, that's what I wanted to say, water next to the volcano were sampled. I don't know exactly where, I searched for it, I don't know exactly where, but I guess like maybe even Spirit Lakes or small lakes, and they show that in these lakes we have this now high abundance of chloride, sulfide, and ammonia, which also shows the release of gases from the volcano.
Yeah.
Again, not as high as in Dante's Peak. You wouldn't have someone, you wouldn't have a boat dissolving in this lake, but yeah.
The acid lake of doom.
The acid lake of doom, yeah. Not at these levels, but yeah.
I'm getting the PTSD attack right now. my god. Go watch the movie. It's actually pretty awesome. At least
And the podcast after you've watched the movie.
Yeah. Exactly, but that's the general trend. You still see evidence of volcanic activity, but everything you would everything you would truly connect to a volcano mostly declines until late to mid-April, something like that.
Yeah.
I would get into early to mid-May.
Yeah, that's okay.
All right. In early to mid-May, once again, only small eruptions. As Thomas has said, fumarolic activity, and it resumes. I actually read that it seemed to increase for a short period of time.
Mm-hmm.
Okay.
Yes.
And the bulge had now grown outwards about 140 meters. And I just need to quote this because the USGS report said it became, quote, unquote, visually conspicuous.
Yeah.
Which
I also noted that.
I mean, you have this bulge which now extended your volcano towards the north for 140 horizontally measured meters. Yeah, it's kind of conspicuous. But once again, nobody could predict what would happen, but it seems so weird in hindsight, but yeah, it's a difficult topic.
I think even if they didn't say that officially, and I don't know that, but at least they personally probably had some opinions on what is going to happen at some point.
Yeah. And at this point, one thing I also found pretty interesting is that mostly the ejected material from the continuous smaller eruptions contained fragmentary material from the volcanic edifice. So this wasn't new material. This wasn't yet anything showing that some new magma had risen up, had erupted. This was mostly reworking of old materials so far. And I think this would indicate that the activity doesn't take place too far towards the surface, that it isn't too shallow, or
these are steam explosions, steam eruptions. They also noted the color of the eruptions that we have during that time, these small eruptions, and they have for example the white cloud, condensation cloud that you see above them. This indicates very nicely that these are steam eruptions, and that means that basically just a very small amount of magma, very, very small amount of hot material gets in contact with groundwater, and then that groundwater expands very quickly. And these are the eruptions that we see. They fracture everything, and they these are where the fragmented material come from. But this was not a major eruption where all the magma at the end was moving to the surface.
But this hydrothermal system, this system of hot groundwaters in the vicinity of the volcano or at the flanks of the volcano, this is going to become important, very important later on.
Oh, yeah. And also the bulge not only grew, but also changed its appearance. So suddenly a second high point evolved that overgrew the other point, and new fractures evolved along the bulge.
Honestly, this is so freaking scary.
Yeah, I mean, it's a mountain. Imagine that it's a mountain just growing.
Maybe it's a giant amoeba.
Yeah, that was I was thinking about.
All of a sudden, there were 2 Mount Saint Helenses.
Or imagine like or what's pickle in English?
Oh, German word of the day. Oh, Jesus.
Yeah, pickle.
I mean, we had die letzten Jahre der Dinosaurier earlier on, but...
That's a sentence. that's the German sentence of the day.
Pickle.
Right? Pimple.
Yeah. Pimple.
Pimple?
Yeah. Pimple?
Right. Imagine having a pimple on your face, but like in the size of a mountain.
Oh dear.
Yeah. I mean, not you having a pimple in the size of a mountain, but a mountain having a pimple.
Quality content.
Yeah, quality. Let's move on. It's extremely scary. That's what I wanted to say.
Like a pimple.
Yeah, seeing a mountain crew in real life is not something that is normal.
Yeah, I can't really let go of this quote. Visually conspicuous. Okay, shall we talk about the eruption?
Yeah, I think we can talk about the day. May 18th.
May 18th.
So for 4 days before May 18th, there were no eruptions. There was also no real increase in activity. So there were no increase in seismic activity. There was no increase in ephemeral activity in that time. It kind of seemed to have ceased. And then, 8:32 o'clock, no precursors before, suddenly a large 5 magnitude or magnitude 5 earthquake occurred. And this earthquake in the end triggered a series of events ending in this large eruption on this day. Yeah. So what happened is that because of this large earthquake, the whole north flank just suddenly failed. It was unstable already because of all the cracks, and also the evolution of this weird bulge that was there, and also because of ephemeral activity, for example. This whole northern flank was very unstable. And did you saw the images on the official report? Like there was a section where they just showed different images of the volcano?
Yeah, do you mean the Rosenquist photograph sequence?
No, I mean some days before the eruption on top like of the volcano where you could see the crater. And it was scary. There were like large fractures. It seemed like it could break down every second.
Yeah.
And that's what happened in the end. The whole northern flank of the mountain, all just suddenly failed.
Yeah. But talking about the Rosenquist photographs, I would like to once again encourage everyone listening to Google Gary Rosenquist. So this is Rosen, Rosenquist, Gary Rosenquist, Mount Saint Helens. Because this is a sequence of images you will then see shortly after this earthquake. And he shot a sequence of images where you can actually see the north flank of Mount Saint Helens sliding down, developing into this debris avalanche. And yeah, what actually then happened is these slides, or the flank of the mountain, developed into two kinds of parts, one lower one and one upper one. They actually split at some point. And at first, a steam blast erupted from the top of the sliding part, of the sliding plane, and a second blast erupted out from in between the two sliding parts, the upper and the lower. But this one in the middle was then actually run by the upper debris avalanche.
Yeah. And this was like, in the end, a large lateral boom. Yeah. And the numbers are just astonishing. So first of all, there were speeds up to 500 kilometers per hour where this material was blasted out. I mean, even higher, like this was the speed of the material itself, but the gases and for example, the vapor and everything sped up, of course, up to Mach 1.
Yeah. For those maybe who don't know, this is the speed of sound.
Oh, yeah. And, yeah.
This was triggered maybe by what we talked about earlier, molten material contacting this hydrothermal system, wasn't it?
Yeah. And it's just an abrupt release of pressure and then boom.
Yeah.
And it had an energy of 24 megatons. Most of it the heat though, but yeah. And it completely destroyed an area of 30 by 20 kilometers. No trees remained in that area. And over 600 square kilometers were just blanked with hot. I mean, some 100 Celsius hot material, just completely blanked. And yeah.
And this is only the blast. This is not even considering the debris avalanche.
Yeah, that's the blast. And of course, all the material that was thrown out through the blast.
Yeah. But the avalanche, for instance, moved 2 to 3 cubic kilometers of rocky material. This avalanche actually also, which I read, it also shallowed out parts of Spirit Lake. So it even went into the Spirit Lake and it just shallowed it out by about 60 meters.
Yeah, and that's
the southern part, that's to say.
And that's also an important point, because now, if we can move on from the giant blast and like get to the points that happened then, or simultaneously, this led to, first of all, a redirection of the water within Spirit Lake, but we also now had all this water that was that existed before as ice, as glaciers on top of the volcano, and all this material, of course, all this water, this ice melts. And now all this water is rushing downwards. And it took everything with that was in the way. And this were, of course, all the trees. This were all the trees from a logging company that was located near the volcano. And it ended in a gigantic lahar. And now let me tell you what a lahar actually is. So lahars are mixtures of water, rock, sand, and mud. They can have up to 60 to 90% of rocks within them. They can have speeds from up to 30 to 60 kilometers per hour. And with rocks, I mean, they can be rocks that are tons. There was an example of, this was another eruption, it was an eruption in Colombia. But still, there was a block with 3,000 tons that moved 30 kilometers away from the mountain through such a lahar. During this eruption in Colombia, because of the lahar, 23,000 people died because it destroyed a city. And yeah, so lahars are actually, even if you thinking about a volcano, you maybe don't directly think as in danger of water. But in the end, these can be even the deadliest outcomes of such an eruption. Because often people also, don't realize that this could be in danger, and then you stand maybe too close to a river near the volcano or something like that.
Yeah, this is a pretty good point, because it's very, very important to consider all kinds of different effects an eruption could have. And as you said, maybe that's not even the first thing people really think about, that water could be a danger associated with volcanoes.
Do we, maybe, I thought before we talked about it, to add this in the end, but maybe we can even talk about the couple that survived this lahar.
What about I would just quickly like to sum up what happened so far, because just to summarize, we had now this magnitude 5 earthquake. Then we had the collapse of the north flank, which created this debris avalanche. At the same time, these two lateral blasts developed, which devastated a huge area. And then the vertical eruption started, meaning that now basically this is cliché volcano image with the huge ash cloud on top of the summit. And then I think it was about 10 minutes after the eruption column really started to grow, this cloud had already reached 20 kilometers high, which was one pretty scary report I read was from an airplane pilot who stated that he saw the eruption cloud, and airliners usually cruise about 10 to 11 kilometers altitude, and this report described this cloud within minutes rising from, below him, in the distance below him to above him. This is double the height.
I mean, to the eruption itself, I want to say something to you.
Mm-hmm.
But yeah, I wanted to talk about the lahars first because they were triggered through this first eruption part.
Yeah, indeed. But this is just where we're at right now. The lahar is also then triggered at this, I think, about the time of the main eruption.
Yeah. Exactly. So, yeah, maybe I'm just going to add the part about these two survivors, and then we can talk about the large eruption itself then.
Mm-hmm.
So there were actually two people. They were a very young couple, 20 years old. Venus Durgan and her boyfriend, Roald Rayton. They were camping in a forest near the mountain. What I found interesting is that they stated they didn't hear the eruption.
Yeah.
That's weird.
Yeah, and this wasn't only them. Actually, we talk about the USGS report pretty much, but the fact sheet and the report on this, it's pretty extensive, especially in just the chronology of the events. And yeah, this was actually a pretty common and pretty weird thing, because for some reason people didn't really hear the eruption close by, although it was heard hundreds of kilometers away. Heard.
Heard. Yeah, I found that was interesting. That was weird.
Have you encountered anything explaining this?
No, I did not.
Me too.
Maybe I overlooked it, but it didn't really count on it.
Interesting.
Yeah, so they realized the volcano was erupting when they heard, first of all, the emergency noises, and then also when they saw the eruption itself rising behind the mountain. Then they tried to fastly throw everything into the car, but the car didn't start. Very like in a movie. So, and during that time, the car already got engulfed by water, so by the lahar. They climbed on top of the car, and then all the material, the trees, the rocks, and everything. And it's just all these trees within the water. There are a lot of images and videos from the lahars itself. Also very encouraging to look at them. Not encouraging to look at them, right? I encourage you to look at them. That's what I want to say. And they got thrown into the water. And basically at that point, the chance of survival is pretty low. However, Rayton, so her boyfriend, could save himself on a log, and he pulled his girlfriend out of the water. And they survived. Yeah, so actually Rayton, so her boyfriend, didn't really had any large problems, but her girlfriend, her wrist got entangled between two large logs, so her whole wrist was fractured and his skin turned down to her bone, basically. No. But both of them survived. That's a really interesting story.
Yeah, and
it must have been scary. Just imagine being in this.
Yeah, and I mean, I read through the eyewitness reports, which were included in the official report, and just these different nuances, things starting from you feel a difference in pressure, you feel pressure change. So many, or at least relatively frequently, people reported that their ears popped. That even some people reported feeling kind of like being pushed down to the ground, or being squished, being pressed together. Starting from things like that, going over to the lightning going on, because this ash cloud, usually these ash clouds have a lot of lightning in them. And just one interesting thing there, did you read about the reports of ball lightning?
Oh, no.
Actually, this was, once again, one has to stress that eyewitness reports are always, especially in situations where, the life of the eyewitness is in danger. You have to be pretty careful interpreting these reports. But there were these reports of ball lightning, and I think, what was it, purple lightning? Red, purple lightning? And this was just imagining what it is like. You are below this ash cloud. It's basically dark. It's nighttime for you. The lightning going on around you, the pressure change, the tremendous noise. I mean, later on there was noise, but at first it wasn't. There wasn't. And yeah, that's pretty scary and pretty unimaginable.
Oh, yeah. Yeah, I mean, that's some force that is difficult to imagine for a human.
No.
Okay, I think move back to the large eruption. So we are back in the Plinian eruption.
Yeah.
Maybe to give you some kind of background knowledge, there are different types of volcanic eruption. I already talked about the Hawaiian style before. We have, for example, also a Vesuvian style. From the Vesuv mountain. And we have also the Plinian eruption style, which is, of course, also, which is named after Plinian the Younger. So also the eruption of the Vesuv mountain in 79 AD. So the large, famous eruption that destroyed Pompeii.
Yeah. And he wrote the first report on any volcano eruption ever. Huh? So
exactly.
That's
why this style.
Yeah.
And that's why this eruption style is named after him.
I remember this from Latin class.
Yeah, we also read that in Latin. I thought this was pretty interesting. The main parts about these eruptions are that they inject material into the stratosphere. So, up to 45 kilometers. I think in the case of Mount Saint Helens, it was like 10 to 30 kilometers. Or, I think around 20 kilometers, yeah.
Yeah, something like that.
Yeah. And they have now there's another new thing that I want to introduce. And this is the Volcanic Explosivity Index, the VEI. This describes the power of a volcanic eruption. And these Plinian eruptions have numbers of 4, 5, and 6. So there are 8 classes of this volcanic explosive index. And what it explains is, first of all, the size overall, so the volume of ejecta, the height of the eruption column, and so some things. For example, an VEI of 1 has an plume height of 1 kilometer and an ejected volume of 10 minus 5. And if we now go to an eruption style of, for example, 5, which was the Mount Saint Helens eruption, then we have a plume height of 20 kilometers or larger and ejected volume of 1 square kilometer, so normed. Again, VI1 had like...
Do you mean cubic kilometer?
Cubic kilometers, yeah.
Okay.
Sorry. So again, VI had like 10 minus 5, and now we're talking already about 1. And this was Mount Saint Helens. It can get up to an VI of 8, and then we're going to talk about more than 1,000 cubic kilometers. So these are the really, really large eruptions. And it's on logarithmic scale. And Mount Saint Helens was at 5, and these Pliny eruptions have VIs of 4, 5, and 6. And then these larger eruptions, we then talk about ultra Plinian. Yeah, that was just wanted to add, because this is an important index to describe the explosivity of a volcano.
Yeah. Pretty interesting. Didn't hear that before.
Yeah. And like such an explosion of an eruption of a VI of 5 basically happens every 50 years, something like that. And then an eruption of VI8 happens like every 10 to 100,000 years. So then we talk about the really large eruptions.
Yeah.
Yeah. Okay. Let's move on with the eruption itself.
Yeah, the really important thing here is that this ash cloud now really spread, and it was blown to the east-northeast direction. And one consequence, once again, you wouldn't really primarily think about is lightning. Forest fires were started. So this ash cloud actually caused a lot of forest fires on its way. And this is pretty tremendous, because ashfall was recorded about 1,500 kilometers eastward from Mount Saint Helens, which is, I think, about half of the United States across. I remember reports from, what was it, Minnesota?
Yeah. Even in Nebraska and Oklahoma, so 1,500 kilometers away, they still saw some of that after the ash, up to 5 centimeters.
Yeah. Snow that isn't snow, and snow that could suffocate you. So that is what the larger consequence was, this huge ash cloud. And actually, last time we talked about airplanes, helicopters not being able to work under these conditions, but actually I found it interesting that there were reports of helicopters going in to rescue people really, not the day of the eruption, I think. I didn't really get the timelines, because this was mostly what you got to see in documentaries, and these documentaries often aren't too precise with the timing. But in general, I would have thought that maybe aircraft wouldn't be able to work for days afterwards, because, the ash hasn't left the air completely too soon, I think. Of course, it's a thing of concentration, but...
Yeah, maybe they flew like really close to the surface, so maybe during that times when they flew, there was not that much ash.
Yeah, but just interesting. Really interesting. Yeah. Also, the airliner report, how he described that this cloud was above him. Of course, it wasn't directly above him, but it was there was still some lateral displacement between the two. But
But if you look at such a large structure, it often seems like it's basically engulfing you.
Yeah, but this eruption then resumed for 9 hours. Juvenile erupted material, so meaning the new material from actual melt, from actual lava, newly erupted, was about 0.2 cubic kilometers. And this just means what was basically hardened rock in the end. This doesn't account for material thrown out or ripped out of the volcano, which had been there before. But this is just what erupted.
Yeah, so the ash itself, of course, is now a larger volume. But if you would compress it back to solid rock, then you would end up with these 0.2 cubic kilometers.
Yeah.
Should I give some numbers here to compare to other eruptions?
Of course, I love statistics if it's done right.
0.2 is actually not that much compared to other eruptions. There's, for example, the very famous Pinatubo eruption in 1991. It's, I think, still the largest eruption that like modern humanity ever. So like with modern, I mean like modern technology in humanity, where we already have modern technology, survived or experienced, and it had 10 cubic kilometers. So again, we had 0.2 with Mount Saint Helens, and now we have 10. But if we go farther back in time, we see even larger and larger eruptions. The Tambora volcano, very famous, in 1815, over 100 cubic kilometers. Yeah. And then we have the Yellowstone volcano, some 600,000 years ago, and it was roughly 1,000 cubic kilometers. And then even the eruption Mount Saint Helens, it seemed like incredibly large, still is tiny compared to these large eruptions in our history.
Yeah. And at the same time, Mount Saint Helens, why it is engraved that much into our memory is mainly because it's been, well, the best documented large eruption in the Western world. So this is this eruption which was documented pretty well, monitored pretty well, and the place. It took place in the US, so many factors contributed to Mount Saint Helens becoming this, stereotypical eruption for many people, or this classic eruption, this first one which comes to mind.
Yeah.
Okay, I would like to transition into decreasing activity.
Yeah.
Because at 5:30 p.m., as I said, about 9 hours, this vertical eruption was really there. At 5:30 p.m., this Plinian eruption decreased in intensity. And until May 21st, minor eruptions resumed. But once again, then the researchers encountered the problem of bad weather, cloud cover.
Maybe one very small thing I want to add to the eruption, to the large eruption itself, because we talked about it at the start of our main part today. These pyroclastic flows, so ash flows. What also happened is that this large column collapses. The material in it is too heavy, and the eruption column collapses, and then all this material is drawn to the surface by gravity. Yeah. And now you have this dry powder of like rock and ash and sand, and this basically acts like a fluid. And then there is gas injected, which makes it even more appear like a fluid. And then heavier objects or other objects can float on top of this layer. And then you have like this extremely hot, like several hundred to thousands of Celsius, traveling up to many 100 kilometers per hour just over the surface. And yeah, everything they encounter during that time is basically burned, completely burned.
Yeah, about a 10-kilometer radius around the summit was pretty much flattened.
Yeah.
And yeah, that was really, I think, the final thing we should have addressed.
Yeah.
Because that's what happens. That's what happens with these eruption columns pretty often, that they just collapse, and then these pyroclastic flows run down the summit area. This is once again also what happened in the movie Dante's Peak in the final part. But in Dante's Peak you had this weird mixture of eruption types. This was this kind of thing where at first you have these lava flows, and at the same time later on you have a pyroclastic flow. And this, once again, I mean, you said that eruption types can even change within one eruption, but not that drastically.
Yeah, that was a bit strange.
Yeah,
overstretched.
Yeah, and in this case, it's you have this dacitic volcanism and you have this Plinian eruption, which is pretty explosive, as we've pointed out, I guess.
Yeah. Because of time, should we go really quickly through what happened after the eruption of the volcano?
Yep, that was what I would like to go into now.
Yeah.
I would just so my plan would be to just summarize the next days, and then I would like to say something about the next years. Only very shortly. Because, the final eruption in May was at the 28th, when a further eruption occurred. And all the way through 1980, this volcano remained active. So the worst eruption was over, but further smaller eruptions in May, June, August, October, and late December occurred. In December, these actually became progressively smaller in volume, less explosive, and a bit more basaltic. So a bit more, you had lava flows. This wasn't as explosive as before.
With basaltic, I don't know if it was directly basaltic, but it was more to the the lower end of silicate.
It was stated slightly more basaltic or mafic to be exact, but
to be mafic,
for the listeners,
that's right.
More basaltic, less explosive. And these eruptions, some of them had ash clouds over 10 kilometers high.
Yeah.
And some, once again, had ash flows and dacite fallout. So still, you wouldn't really want to be around this volcano for the remainder of the year. And this was 1980. From 1980 to 1986, there were further episodic eruptions with even dome building episodes.
And small lahars.
Yeah, small lahars. Which just goes to show we always think of this one cataclysmic event. And actually, ever since then, there has been activity. I mean, after 1986... we enter an episode where this dome just keeps growing. So mostly I read that there were some hydrothermal explosions. So no, I misread my notes, because from 1989 to 2001 there were hydrothermal explosions. But the material thrown out by these explosions wasn't new material. It was material that had been there from previous eruptions. So no eruption in the strict sense. And then from 2004 to 2008, and we are going to link to this, at least on YouTube.
Yeah.
There is even
so find all our papers and reports and internet sites, websites. You will find it all in the description of at least YouTube. Yeah.
Exactly, and at least the most important sources. So like the USGS site is really, really good. It gives you a good overview of all the things we talked about.
It has good fact sheets. We also use that for our lecture, actually, in university.
Yeah.
Yeah.
But 2004 to 2008 at Mount Saint Helens, this was really what I meant. There is not really eruptive activity. At least that's what I read. It's mostly that this new dome, because when an eruption ends, and maybe you would like to explain a bit further how this works, but often a dome forms, which encloses the new crater from which material erupted. And this dome, after forming, it grew a little bit, but what I read was that what came out of the top, attributing to this growth, was already hardened material. I don't know the mechanisms behind that, but yeah.
Yeah, so the material, I think it's still like lava, but the material hardens or crystallizes probably within the vent or like the upper region. So the material is rising very slowly, and then it builds up on top like these domes. You don't have that with basaltic material. This is only andesite or dacite or regular Jesus, these names in English, rhyolite, stuff like this. So only this very viscous material. Yeah, and they will build up these domes, these protrusions. They're sometimes called of material.
Yeah.
Yeah, I mean it's still pretty large. In 2006, it grew up to over 430 meters. It moved, so tilt meters measured a movement of 6 meters per day southwards. It is still, that's a large number, 38 million cubic meters of material.
Yeah.
At least stated in that fact sheet. So that's still a lot of material. That's not like very minor.
Do you know about very recent activity?
No, so after in 2008, we had some small steam eruptions or explosions, and then we had 2 large earthquakes with 2.9 and 2.7, and then it was silence. Nothing. So I searched if there was anything, and I saw like there were some earthquakes, but they were then later explained to be of tectonic activity, so of the subduction zone. Nothing really. I mean, maybe there are gases or anything like that, but it isn't really talked about in any paper I searched for. So, yeah, the volcano is silent again.
Yeah, which doesn't have to say that it's. I mean, it's not inactive. It's not extinct. No, I think that's safe to say, but yeah, I mean, the future, and that's maybe what we want to get across here is, yeah, it's looking like it is going to erupt again, because I would say there isn't really much to say that it isn't. It's been active until a few years ago.
Yeah.
And as we've seen, periods of activity, well, they are pretty large. Even breaks between eruptions can be pretty large. And honestly, centuries don't have to mean anything. Centuries of silence don't have to mean anything.
Yeah, I mean, that's like the high difficulty of monitoring and trying to first of all, monitoring, of course, but also trying to inform the public, for example, or decision making. So I've actually have a number from our lecture that 80% of like all the probable activity that we see at these eruptions do not lead to eruption in the end. And now, for example, you have, the Vesuvian volcano next to Neapel. It is probable that it's going to erupt again. When? Difficult to say. But what are we going to do now? Neapel has some millions of inhabitants. So what do we do? Is there a small earthquake and we evacuate everyone?
Yeah.
I mean, this is a million people city. What are we going to do now? These are extremely difficult discussions because, as you've seen, it's very unpredictable in many cases. It seems like it's going to erupt and then silence. And then suddenly, some weeks later, there it is. It's so difficult to say that, in the end, making decisions in these scenarios can decide over death and life, but it's extremely difficult.
Yeah, there is a lot attached to that. And
yeah,
I think Mount Saint Helens really is an example a lot was learned from. At least that's stressed again and again, because I mean, there was a very intense observation, and even back in the day, in the report about Mount Saint Helens, it was even stated that it was hoped that this surveillance network would be sufficient. But in the end, it wasn't. And honestly, maybe there wasn't even a way for it to be sufficient at any point. I mean,
I read that they looked into if the geologists made some wrong predictions or had some, that some of the deaths were because of wrong decisions of the geologists. But this is so, it's such a difficult job. It's so difficult to do. And you basically work against everyone. The people want back to their homes. The government probably want the economy back on and stuff like that. So you work against everyone in the end, and it's such a difficult decision. So maybe not search the fault at these guys.
Yeah, they are doing their job, and they were trying to,
of course,
protect people. And even one geologist unfortunately passed away when he was at watch close to Mount Saint Helens.
Yeah, David Alexander Johnston. So he was at Coldwater 2. This was the observation state, very, very close to the volcano. And it was also directly in the area that the extreme blast, lateral blast, just completely destroyed. And so he didn't survive.
Yep, and that's really these people risk their lives trying to predict volcanic eruptions to save other people. And this is a really hard job, and honestly, I wouldn't want to. I really wouldn't want to exchange my job with the one of a volcanologist just because of the responsibility you have. And in the case of Mount Saint Helens, honestly, difficult. It was a very difficult situation. It was a very unfortunate outcome because, over 50 people died during this eruption around the area. I think everyone was recovered. At least everyone was identified, I think. No one was...
No, not everyone.
But most, at least.
Most. But for example, David A. Johnston, so the geologist, David X. A. Johnston, he wasn't able to be recovered. Also Harry Truman, because they were in this area of the lateral blast, and we talk about heats where. So what I read is that they basically were vaporized within seconds. So
yeah,
probably not going to find anything there.
Yeah. And
there is this famous picture of Johnston, or this image of Johnston, where he is like, it was like 13 hours before the eruption. Is also the first image when you search for him on and I don't know, just imagine this being 13 hours before like everything was destroyed. Oh, he was also the guy that this was the first to report the eruption. Yeah. He was the first one, and he transmitted Vancouver, this is it, and then seconds later, basically, he was dead.
Yeah, which is... Yeah, I don't know. Just thinking that this were the last words of a person, just hearing this is it. And everyone had to know what this meant.
Yeah.
Yeah, it's kind of makes me shake a little bit.
Yeah, that's true.
Yeah, I think that Mount Saint Helens, it's for volcanologists, and this is what I read a couple of times, that this was really an important eruption just because these new I don't know, these monitoring techniques weren't tried there the first time, but the the exact method of observation, I think, of monitoring.
Yeah, it was like the first time that we really used modern...
Yeah, and where it was possible to employ all these different surveillance techniques
that we still use today.
Yeah. And honestly, I'm struggling a little bit to come up with a real conclusion, because it's been a very tragic incident. It's been a very informative event, and at the same time, it has also shown how unpredictable these situations are. So, really,
how difficult it is to work with it.
Yeah, it's how difficult it is to work with it, how difficult it is to actually predict anything, maybe. I mean, of course, there are tendencies, like increasing activity levels indicated via earthquakes, via chemical proxies and lakes nearby, or things like that, but I have very mixed feelings thinking about this. Like, it's been a positive thing for volcanology. It's been a very tragic event for the human beings around this volcano and stuff like this.
Yeah, but the point is... Yeah, sorry, but the point is that this is nature. We can't do anything against that. That's what we have to live with.
Exactly, and stuff like this is going to happen again. It's going to happen again there, and it's going to happen anywhere. I mean, just think about the Eifel in Germany, which is a volcanic area which is not extinct. It's just inactive currently.
Sleeping,
Yeah, and this is, I mean, who in Germany actually thinks of a volcano being active just next door? I mean, especially here in Germany, I think we often feel very protected because we don't really have to deal with too many natural disasters over here. And I think, honestly, I wouldn't really think that anybody I know of would actually know about a volcano in the middle of Germany, which is active, or dormant. I don't know. Maybe you know more about that, but
it's sleeping. But
yeah,
there's still signs of activity. There's, for example, CO2 escaping from the water, from the sea, from the lake.
Yeah.
or small earthquakes. But yeah, maybe a topic for another episode. Oh, volcanoes probably not going to be the last time that we talked about volcanoes, because there's so much to talk about volcanoes.
Yeah, and I guess we love them.
Yeah, definitely interesting to talk about. Maybe because we talked about Henry Truman and we wanted to say how he died, or like what happened to him. Maybe we should give that a quick update. So he wouldn't want to evacuate. Again, he was a guy saying, if the mountain goes, I'm going with it. He's also a guy that says these goddamn geologists with the hair down their butts wouldn't pay no attention to the good old Truman. During this time, he became a folk hero because he was like fighting against the officials and stuff like that. The last try to persuade him to flee was a day before the eruption. It didn't happen. I read, not in the personal report, but I read in the original report, but I read somewhere else that actually his daughter was trying to pursue him in the evening before. But yeah, he was at Spirit Lake, and that was where the blast hit, so he was probably dead within seconds. Yeah. And that's why it's so difficult. It's like always working. I mean, there's a folk hero because he fights against the officials. I mean, that's why it's so difficult to work with that stuff.
Yeah. I mean, these people were really only trying to save lives, and yeah. I mean, I didn't read as much as you did about him, but he really gives you a pretty much anti-science vibe, and I mean, it's his thing. If he doesn't want to leave, and he's been living there for his entire life, it's one thing, but it's a different thing.
It's like how the media looks at it. Or like the people look at it. That's where I have like my problem with it.
But was he really someone who actively said that this volcano wouldn't erupt?
It's contradicting. I don't think that he actually really truly had an idea of it. Like at one point he's like, yeah, if it's erupting, I'm going with it. He also said like, I don't have any idea whether it will blow up, but I don't believe to the point that I'm going to back up. But at some other point he was like, no, nothing is gonna happen there. So very contradicting. Yeah. Anyway, we've talked now a long time about a volcano. You probably can cut some stuff, but yeah.
Yeah.
Are
absolutely.
you happy with our statement that was kind of involved then with Harry Truman? And yeah, do you want to add something?
Honestly, as I said, I'm actually pretty torn.
Yeah.
Actually, I didn't really expect that, but right now there are very many emotions going on right now with me.
That's a good point, because normally before I always saw the eruption itself, as an eruption, as a geological event. But now reading like the eyewitnesses are now talking about it, just kind of, it's like a small hole in the air that is like, it was like the first time that I really felt something when talking about it.
Yeah, it's just, it really hit me when we got into the positives and the negatives, because we learned a lot from that. And I mean, often that's the case. When these things happen, we can learn from them. It's unfortunate that they happen, but we can learn from them, and we can do things, or we can react properly the next time. On the other hand, just think about the lives that were lost. Just think about all the area that was destroyed, and this and that, and volcanologists risking their lives for others. It's acts of heroism, or especially from the people who went in there to save others.
Yeah. As you said that, I have the picture or the image of David A. Johnston, how he's sitting there smiling into the camera on a small chair 13 hours before everything went down.
It's haunting.
Yeah.
Yeah, but this time I won't say that I'm happy with this final note, but yeah, that's how I feel.
Yeah, and it's a good note.
Yeah.
And I think there's nothing that I can add that we would have not already said before, so.
Okay. So then, that was our episode recapping not only the events of Mount Saint Helens 1980, but hopefully giving you guys an insight into the general history of Mount Saint Helens and showing how difficult volcanoes are to interpret and to predict.
And also definitely not the last episode of volcanoes. There's so many volcanoes on Earth and in history, and then there are also volcanoes on other planets, so
Olympus Mons.
For example.
If you don't know what it is, Google it. It's a great...
I'm already waiting for the new...
Yeah, you won't be disappointed. Olympus Mons. Okay, but we haven't really decided on anything for the next episode, so no announcement, I guess.
Yep. Thanks for listening to us. Subscribing, yeah. Consider subscribing if you want to listen to more stuff from us. And otherwise, thank you very much and bye.
Bye, guys.
Thanks for listening to the RockyTerrain podcast. If you enjoyed listening to us, please consider subscribing on your favorite podcast platform. Everything addressed in this podcast reflects our own opinion. You can contact us at 4.5gainthemaking@gmail.com. That is 4.5gainthemaking@gmail.com. All music used is from Kevin MacLeod and was downloaded from filmmusic.io under the Creative Commons license. That is heavy interlude for intro and outro, and home bass groove for intermission. Hello to recording Dennis in the future. Hi. I wanted to be funny, but I'm not funny, so sorry. I'm not as natural as you in these segments when I'm not here and you're just talking something. I never realized how weird it is to sit alone in front of the recording. 10 reasons why planets are better than pterosaurs. Reason 1. Planets are still alive.
I guess I interrupted you.